Hey everyone. So I thought today I would do something a little bit different. Instead of just reviewing, I thought I'd show you something new. Now, look, none of this stuff is going to get graded, but nonetheless, I'm going to show you something that I think has value, and hopefully I can give you enough examples where you might find value in it too. So this thing is called a Goodness of Fit, and that's a really simple name, Goodness of Fit. And basically what it allows us to do is it allows us to decide if certain categories have any differences among them. All right, so in this example, I have chocolate, vanilla, strawberry. You could do it with sports. If you wanted to see if football, basketball, and baseball were viewed similarly, you could do it with certain math teachers and see how many people preferred certain math teachers. So there's all different kinds of ways. All right, but I have three categories, chocolate, vanilla, and strawberry. And let's say that I have this suspicion that more people like chocolate than vanilla and strawberry. And because I think that's true, I want to have more chocolate on site than vanilla and strawberry. So I take a sample. I have 60 people come, and if they all liked chocolate, vanilla, and strawberry the exact same, I would expect 20-20-20. That's what I would expect if everything was the same. But what I observe is 28 prefer chocolate, 16 prefer vanilla, and 16 prefer strawberry. And if I just stop there, I'd say, hey, there's proof, there's evidence. But we have to run this through this hypothesis test to see if, in fact, there is evidence, because we just don't take it at face value. So this is a new formula. You have not seen this formula. This symbol, this is an X. It's not really an X. It's a Greek symbol, but it's an X with a little 2, and it's pronounced chi squared. That's C-H-I, but it's pronounced chi squared. And this symbol means add things up. And down here, I did all the math for us. Okay, so I have three things I have to add. I have to add this thing plus this thing plus this thing. So here's chocolate. 28 is my observed, minus 20 is the expected. I squared that, divided by 20. That gave me 3.2. Then I slid over, this is vanilla, and that gave me 0.8, and this is strawberry, and that gave me 0.8. I added those up and I got a number at 4.8, okay? Now, in the past, when you've done hypothesis tests, you've gotten a z-score, and then you went into your chart to get a p-value. And then you compared that p-value to some alpha level, and then that determined whether or not you rejected the null or you accepted the null, okay? So here, in this Goodness of Fit, you don't have a chart to test, and this curve isn't normal. This curve is actually skewed. I probably have it drawn poorly, but it has more of that shape than a normal curve. Okay, so what this 4.8 has to be compared to is it has to be compared to some other number that we would use a different chart. And I don't feel like right now going into what that chart is. All I'm going to tell you is this number gets compared to that number. And I know that you are aware that 4.8 is less than 5.991. So this would be our shaded area or our reject region. So if we got a number that was bigger than that, it would fall in this reject region. We got a number that's less than that number. 4.8 falls here. And because it's less than that number, this is not the reject region. So we circle this. This is the null hypothesis. We do not reject the null. So despite the evidence sort of looking like we should reject the null, and it sort of looks like there should be a preference, our chi-squared test proves or it gives us enough evidence to say that there is no preference. Okay, so I'll slowly start to give you some Goodness of Fit tests that you could run. I'll try to be creative with certain categories, but nonetheless, I was delivering some Brewsters the other day, and I thought, hey, potentially this is something that the folks at Brewsters actually might try to consider. What flavors should they keep more of in this certain time right now? So thank you. Hope everyone's doing okay, and hang in there.